Hello Internet, today we're going to be looking at LINQ streams, or how to use LINQ in C#. So LINQ is one of those features in C# that some people are very familiar with and really like using, and some people have no idea how it works, and it can be really intimidating to start because the syntax for LINQ can be a little bit different than what you might normally be familiar with if you're just working with data structures yourself. So we're going to take a little look at that. And this is hopefully going to cover some of the basics of things you can do with LINQ and how things work behind the scenes. I'm no expert, and there's definitely gaps in my knowledge on this subject. So we're going to do mostly introduction stuff that kind of covers, it should give you a good foundation and you can kind of explore from there. We're mostly going to be using the syntactic way. So there's two ways to write a LINQ query. I don't ever remember the first one. It's very SQL-like. And then the other one is very basic and it just extends the enumerable type. So that's sort of what we're going to be starting with. So a basic example of LINQ is going to be if, let's say we create a new collection, a new list, and we'll just create it of, say, integers. So create a new int array and we'll just stick some numbers in there. So 1, 2, 3, 4. That's not a 3. There we go. And let's just grab the sum of that. So we're already using LINQ. This is probably the most basic way to do it. I don't know what these functions are called, but they're finalizers. And what that means is they complete a function. That's important because LINQ is lazily evaluated, which means that some things don't happen immediately when you call them. They kind of get scheduled, and then when you complete the function, they get executed. Which means if you're not careful, you can actually execute very complicated instructions like sorts or something multiple times just because you access the same LINQ query instead of computing it and actually storing the results. So that's one of the things. We're just going to do a really basic sum. So all this is going to do is take a set of integers and calculate the sum of them. So normally you could do this with a for loop or something. LINQ gives you a custom function that lets you do this. They all just extend the enumerable type, which means any list or array or anything else, you're going to be able to just run these functions on, and they can all just string together. So let's print this out so we actually know what's going on. And so 1, 2, 3, and 4 should give us 10, I'm hoping, if my math is correct. I hope I don't get that math wrong. So this will just print out hello world, and then on the next line it should print out 10, and then we can read our line. So hopefully just a really basic way to do LINQ. It can do a lot more than this, and we're gonna walk through that in a second. We got hello world and 10. So if I just hit type something, hit enter, we're good. So now let's get into something a little bit more interesting. So we already have this. Let's only sum the odd numbers. So we're just going to select. Let's not select them. Sure. So we're going to do a where clause, which is going to say for all of these integers, where they're equal to some condition. I think we're going to do like is odd or something. Then sum them. So we're only going to sum the odd numbers. So instead of 10, now we should get 4. Where is lazily evaluated, like I was talking about earlier, which means if I were to pull this out and save it in some variable, let's just do that. So how can we show that? I think there's a better way. Let's do a variable. Let's just store a list in here. And that's just going to be our raw list. We don't need to do anything else with it. And let's actually make it a list instead of an array. Not an array list, just a list would work. There we go. Pretty sure that'll end up working eventually. Cool. So that should build us an actual list. It's important to use a list for this example instead of an array, because I'm actually going to be modifying the object and I'm not going to be inserting anything. We could, I suppose this would have worked too, if we go back and just do a normal array. I can modify the values in the array, but if I ever try to set that value, it's not going to work. With a list, I could add new elements if I wanted to, and it wouldn't destroy the reference. Now, let's just keep it as an array. That should work for us. And then in here, we are going to take our filtered list and sum it. We don't have a filtered list, so let's add one of those. Filtered list is going to be equal to our list, where our integer, sure, mod 2 is equal to 1. So this should get all the odd things in our list, so 1 and 3. Now if I run this, we should get 4 from that sum, unless I did my where wrong, but I'm pretty sure we're going to get a 4. There we go. So that's great. So we expect 4. Now I have the filtered list there, and I still have the list. So what happens if I change an element in the list? If this is lazily evaluated, the where it hasn't been executed at this point, it's just been scheduled. It's something that's going to happen, but hasn't necessarily happened yet. And so if I schedule this on the list and actually modify that, so let's say that first element, the 1 there, I'm going to make that a 9. So it will still be found, but now our result should be 12 instead of 1, or instead of 4. So that's sort of, if this is working, we just changed our value after calculating it, which shows one of the concerns, and especially if you're doing orders, those are complicated things, and they're going to take a long time in some cases, especially for large data sets. And so if you accidentally start recalculating that every single time, you are going to be doing a lot of useless work that you don't need to do, and is just wasting your time and everybody else's time. So as you can see, we got a 12 here, which means lazily evaluated. I think that's the best way I can show that. Effectively, it just means it's not evaluated until you actually compute the result. We can continue to modify this. The where is one of the more common things you're going to be using. The other one is a select. So we have this filtered list. I'm going to take that out because that's just going to complicate things. We're summing up our odd things. Let's, for all of them, for all of our odd numbers, let's double them. So let's take our integer and just say integer times 2. So this will, instead of adding 1 and 3 now, we're adding 2 and 6. So a select is a way to transform data. It allows you to take some input and give some output that is of a different type or has been modified in some way. In this case, we're just doubling it. You can do anything you want. Whatever the result of the right side of this function is, that's what gets passed down. So it gives you a way to really easily change data that you might want to do something. So if you're given like a set of, say, state names, you may go and look up their zip code or something like that. That's a very United States reference, but okay, we'll go with that. So this should give us 8. Because we took 1 and 3, and then we doubled them to 2 and 6, and then summed them. So that is probably the easiest way to do like the basic things. Select and where are probably, you can do 90% of what you need using just those. And they're just probably the easiest things to use. There's a whole bunch of other things, like some. If I just hit period, there is a lot of other functions here. These are all just extensions of the enumerable type. If you include the System.Linq namespace in your project, you're going to get all of these. And so we can calculate, say, the minimum value of these. So if I plug this in, we should get 2, because we'll get 2 and 6, and 2 will be the result. You can do a maximum, you can order them, you can do anything you want. The cool thing about LINQ being lazily evaluated is it's not really limited to just static lists. One of the cool things you can do is actually create infinite lists, because since your code isn't evaluated at the time it's run, you can actually create a data type that just is generated procedurally. And so since it's generated procedurally, maybe from previous calculations, you can just keep going. And so the way that looks is, let's say we want to create a function. Let's create a static. It has to return an enumerable type. So IEnumerable of, we're working with integers, so let's just do that. And let's just create a set of positive integers. So this function is going to return every positive integer. And the way that's going to work is, we could do an infinite loop. We could actually do while true and just loop here. And we'll start at, say, int current index equals 0. And then we'll yield return the current index plus plus. That's not right because we need to start at 1, but you get the idea. This will actually go beyond just, is this correct? Why doesn't it like this? Maybe that doesn't make any sense. Okay, I need to declare it as an IEnumerable and not give it a generic argument. Okay, I thought that accepted generic arguments. Well, today I learned. It should still work, but that was weird. So anyway, we have this current index. We're starting at the current index, and then we're just going to repeat and create an infinite loop. The way this yield works is if you're familiar with concurrent programming, it's similar to a coroutine. And so instead of restarting your function every single time you call it from the start, a yield function doesn't do that. Instead, it's going to run the function, hit this yield, and return, which effectively outputs the first element in your iterable or in your enumerable type. And then when you call it a second time, it's going to begin right afterwards. So at the very next step, which is going to be incrementing the index, and then it's going to go and do all that other stuff. The incrementing the index probably already happened, and it will just start at the while. But you sort of get the idea. It creates an infinite loop, but that infinite loop returns every single time. It's just going to, every single time we call this, it's going to return a new value. And so with an enumerable type, Linq or C# knows that this is just a list of things. It's going to generate a thing. So we can actually plug that in here. So instead of doing this list, let's just give it our positive integers. Now, this is going to still create an infinite loop because we're still going to infinitely loop over all of this. And so the problem with that, or the way to solve that rather, is there's two functions. It really doesn't like me using this enumerable type. I may have this wrong because I don't use these super often. It's not something I've found particularly useful in like common use, but maybe generic collections. There we go. Okay, I was just missing a namespace there. There's two namespaces. The System.Collections has the original stuff that was there prior to generics and some of the general types. And then the generic functions are in collections.generic. I was missing that, which is why we were getting those errors previously and why nothing was working. So now we get this infinite enumerable list of positive integers. It's not infinite because we're going to have an int overflow, and that's probably not great, but there it is. The general idea here is we can skip or take elements. And so the way this works is a skip is if I say this is starting at 1, if I skip 3 elements, we're going to skip 1, 2, and 3, which means the first element in this list after this function is 4. And then take is going to take however many elements. So since the first element is 4, if I want 4, 5, and 6, I can take 3 elements. So this is for the set of all positive integers, I'm skipping the first 3. So 1, 2, and 3 get skipped, and then 4, 5, and 6 get taken and used in this function. And since 5 is the only one we're actually going to be using because of this where block, we should just get 5 out of this. Actually, we'll get 10 because it's doubled. But you're sort of getting the idea and why hopefully you can kind of see how these functions have started compounding and kind of building on one another, because we've taken all of these really simple concepts and we've built this, and it's just sort of adding all of these new things one after the other. Hopefully that's kind of helping to explain it, but that's really like the core of it. There's a whole bunch of other functions you can use. You can order things. That's really useful if you just need to sort something really quickly, and a bunch of other things. Different frameworks will also support that. So if you need to interact with a database, Entity Framework, for example, will allow you to make database calls as LINQ. And behind the scenes, instead of computing the thing with a min, what it actually does is compose it into a SQL query and send that over to your database, which can be useful for a whole bunch of reasons. It's not necessarily the most efficient queries that it creates, because those are all auto-generated. And this syntax doesn't necessarily line up with SQL syntax, but you sort of get the idea. There's a lot of things, a lot of different frameworks will also support this, so APIs. You can query Twitter using LINQ. So I'll kind of leave it here. I think this kind of covers the basics of LINQ. If there's other questions or you guys are a little bit confused or want to explore something more complicated than this, let me know, but I kind of want to keep it short and hopefully to the point so it doesn't go too crazy. And I think this kind of covers a lot of the basic things you need to know. Some of the core functions, how to create an infinite list, how lazy evaluation works, and things like that. As long as you keep lazy evaluation in the back of your head, LINQ shouldn't cause you any issues. If you forget that though, weird things can happen. And it can be a little bit hard to figure out what happened, because your stack trace may not always result in what you think it should. So as an example, this is not a good idea, but let's do it anyway. Let's throw a new null pointer exception. That may be the Java name, so that may not work. Yep, definitely isn't a thing. Null reference exception. Sure. Doesn't really matter what type of exception we're throwing. We're just going to throw an exception because that's what we want to do. That doesn't like it because we're not actually returning anything. So this example is getting more complicated than I had wanted, but we'll just return our integer after we've thrown the exception. So that's never going to get called. That should be fine. We don't really care that it's not called. It's just an example. But the point here is if you get this exception, it can be really weird. The stack trace isn't necessarily going to point you here. And Java has the same issue if you use Java Streams. I've done a video on Java Streams as well, by the way. But you get this. Visual Studio actually does know what's going on because we're actually getting the exception highlighted. But if you look, you're not going to be able to see this because Visual Studio has made them very small. But the stack trace, let's see if I can get this bigger. Maybe that's a little bit better. Is in here, which isn't super descriptive. We've got something coming out of Visual Studio, but then we got this System.Linq enumerable where select enumerable iterator move next at the LINQ min. So you notice it's lazily evaluated. So our where we didn't get a exception at when we invoked where. We got it when we invoked min. So if those are in two different classes, for example, I don't recommend that, but if they are, you won't see the exception in the same place that it actually occurred. You'll see it at wherever it was evaluated, which can be a little bit difficult to track down, especially if you start composing more complicated queries. So that's something to be a little bit aware of, is try to keep things concise and don't just create a massive LINQ query that goes all over your program and does all the things, because you'll run into an issue and have no idea how to fix it. But if you keep things relatively simple and modular, sort of like we did here, it should be fairly easy to get started with, and you shouldn't run into too many issues. and hopefully the ones you do run into are relatively straightforward. But I'll leave it here because that example kind of wraps everything up. So if there's other things you guys want to learn about this, let me know and we can definitely look into them. But I think that's it for now. So until next time, see you, Internet.